Hello everyone, welcome back. In the previous video, we started a conversation about radical equation. We checked one example and figured out two things we need to do when we solve this equation. Isolate the square root and get rid of the square root symbol by squaring both sides of the equation. This is the major strategy we use when we solve this equation. So in this video, we are going to practice more examples so everyone is ready to master this topic. Okay, let's check the first example here. So again, as you can see, this time we have something different in front of square root symbol. So, but again, very important, we need to isolate the square root. Like you need to move everything around the square root to the other side so you can isolate it. How do we do that? Inverse operations starting with the very outside -5. So now I have this. So some students might say, so how do I do it? Can I square both sides? Yes, you can, but my idea is you can always simplify the equation so you can make your next step easier and you don't need to deal with a big number. How do we do that? So some students might wonder, what is the 3 here? Is this adding, 3 adding square root or 3 times or 3 divide? Is actually this, you do not see the same as any symbol here, it meaning multiplication. It's actually 3 times the whole thing, but when we write this, we always write 3 with this. So in order to get rid of 3, we need to, yes, you are correct, divide by 3 for both sides. Now 3 is gone. So now I can finally have square root isolated. And since this is isolated, now I can square it. So they do not have square root symbol anymore. I just need to continue solve like a regular equation. Again, the reason we got 9 is 3 times 3. So now I can just -1. And then we solve it divided by 2. So the final answer is 4. And also it's always a good habit to check the answer. So let's just quickly do a mental math here. We can do 2 times 4 plus 1, which is 9, and square root of 9, which is 3. So 3 times 3, let's do that. -5 is going to be 9 minus 5 equal 4. Check. See, we got right. This is how we solve it. Let's check the next example. This example is a little bit different, right? We do not have just one square root. Instead, we have 2 on the 2 sides of the equation. So how do we do that? Some students probably already figure out the best way to start because since we have square root on the 2 sides, it's already isolated on each side. How about we just square them? Oh, sorry. How about we just, square them? So now I can get rid of this square root symbol. So I just need to write down whatever inside now because the square root is gone. Now I just solve like a regular equation. Some students want to start with numbers, like -3, perfectly fine. Some students want to move 4x to the other side, also perfectly fine. So now I just need to finish everything like a regular way and solve it. So x equals 6. Some students might wonder, can I write down x equals 6? They are equivalent. This is perfectly fine. This is right. This is right because the equation meaning 2 sides are equivalent. Okay, so to save our time, I'm not going to check this one now, but it is always a good idea to put the solution into the equation to check if you get it correct. Okay, next, new example. Okay, so now you see, before we have just the 2 square root, right? Now we have something in the front. So how should I do that? Some students, can I divide by 3 then? This idea is not bad, but as you can see, when we divide by 3, there's nothing simplified. Instead, we still need to deal with fractions, so I don't think it's really convenient idea. So this time, since we have square root on 2 sides, I'm still gonna square them. So now I have square root gone. So some students might say, oh, I have x6 and we just bring 3 down. Be careful, because this exponents 2 is actually applied to 3, is applied to square root. So that's why it's not just 3, instead it's 9. 3 times 3 is 9, okay? So that's why we have this number. We put a parenthesis because we do not want to mess up like the coefficient or the constant term. This is just the other side. Now, some students, when you see the parenthesis, we can just use, you are correct, distributive property like euro. And again, I always prefer to move the variable first. I just do it. And also I like to keep the positive 1. So that's how do I do this. And then I just continue. Oh my, I'm so sorry. I made a mistake, did I? Okay, so let's redo it. So 9x here, 9 times 6 is 54. I'm so sorry. Now we have 54. So, and then as you can see here, we have variable here. I just need move 54 to the other side. And then it's going to be negative 40. And we divide by 10. The final answer is going to be negative 4. Do not forget the negative sign here. Okay, that's how we solve it. And again, it's always a good idea to put the number into the equation to double check if you get it correct. And sorry for the mistakes. Okay, so now let's check the last example for this video. Okay, this time, as you can see, is a little bit different. We have numbers here, we have numbers there. Some students might say, can I just square it? It's actually correct. So how about we try this way, and later I want to demonstrate a little bit different way to recheck this one. So since they have this, and do not forget it's going to look like this way. Because once we squared it, the number will be squared too. So 6 times 6 is 36. And then we use distributive property. I will guarantee this time I'm not going to make mistakes. So 9 times 2x, 18x, and 9 times 6, 54. And this one, this is going to be 108, 36 times 3, and then 36x. So we just continue doing this. Plus 36, plus 36. Again, I just prefer to deal with variables first. And this is going to be 54, right? And then minus 54 equals 108. Last, I'm going to plus 54 on both sides so I can isolate this one. Then it's going to be 6 and 1. Let me double check. I think it's correct. And then we divide by 54. And you want to know that x is 3 because 162 is a multiple of 54. Okay, so the different way I want to share with you is I'm still going to look at the same equation here. Let me just rewrite here so it's easier for you to see. But as I mentioned, I personally prefer to simplify equation as much as I can, so I don't need to deal with a bigger number. So since it's 3 and 6, I know, oh, 6 and actually divisible by 3, so I'm going to divide by 3 for both sides. So now I do not have this coefficient in front of this, but this part is become 2 because 6 divided by 3 is 2. And then I'm going to square both sides since there's nothing more for me to simplify, and I can just take off this square root. But 2 squared is 4 because 2 times 2 is 4, so I still need to deal with this. Distributive property is always a good idea to deal with parentheses. Again, I'm not going to make mistake. Okay, so 4 times 3 is 12, 4 times x, 4x. Continue. Again, I prefer to deal with variables, but if you prefer to deal with numbers, be everything you can, okay? This is perfectly fine. And then solve like a regular equation. So 6 equals 18. I copy down here, divide by 6, and voila, we have exactly same answer. So again, it's nothing wrong to use this way, but if you prefer to like simplify and to deal with a smaller number, you can always observe the number first to see if you can divide or multiply to get rid of certain things like get rid of fractions or make the number smaller, then you solve it, okay? So that's all the example I want to share with you to deal with this kind of radical equations. In the next video, I want to show you a special case which sometimes radical equation can have no solution. So see you soon, everyone.